Hey, what's up? Welcome to this new video. This one is paper 1 of October-November 2008. Now, with that being said, let's move on to question number 1. So here we have to find the value of the coefficient of x squared in this expansion. Okay, so one by one. Again, we have to understand we only care about the term in x squared, and we have to provide the coefficient, which is the value of a in this expansion. So one by one, if you were to expand this, you will first write 6 combination something, and the first term is x over 2 multiplied by 2 over x. Now we have to choose the power here so that when you expand you will have something in x squared. Again, this is done by trial and error. I don't know exactly which one it is going to be, but I can try in my mind to see what's going to happen. So the power here can take the value of 0, 1, 2, 3, 4, 5 and 06. I can choose this to be, let's think, I can choose this to be the value of 2. This is 2, that will be 2 here. 6 minus 2, that will be 4. Now we can expand and see what happened. So 6 choose 2, that will be 15. That will be x power 4 over 2 power 4 will be the value of 16. And that will be 4 over x squared. Now we can simplify very directly. This will cancel out. You will have 2 here, and here we have 1, 4. 15 divided by 4 will be 3.75 x squared. However, the coefficient is only this one, so your answer will be 3.75 as your answer. Let's move on to the next question. So here we have to prove this ID. So let's begin from the left hand side to show it equals to the right hand side. So at first we have 1 plus sin x over cos x plus cos x over 1 plus sin x. Now obviously the base are different. We can make them the same by applying LCM. Multiply them by each other, you will have cos x 1 plus sin x. Then cross multiply, you will have 1 plus sin x squared plus cos square x. Simplify. 1 plus 2 sin x plus sin square x plus cos square x. That will become cos x and 1 plus sin x. Now obviously this one is what? Sin square x plus cos square x, that will be 1, right? So 1 plus 1 is 2. You have 2 plus 2 sin x over the value of cos x 1 plus sin x. This is going to be 2 and 2 are the same. We factorize, that will be 1 plus sin x over the value of cos x 1 plus sin x. So this and this will cancel out, so obviously at the end you will just have 2 over cos x. That is part 2. I mean, this is just very simple. We just have to follow step by step and then prove the left hand side is equal to the right hand side. Now for this question, the first term of an arithmetic progression is 6. Now we know the first term is 6, and we also know the type of progression is an AP. Now we can write down all the formulas we know. The n term will be a plus n minus 1 times d, and the sum of the first n term will be half times n 2a plus n minus 1 times d. Great, but they are also given to you. You don't need to memorize the formula neither. Now the fifth term is 12, so fifth term, that will be 12. Okay, the progression has n terms, and the sum of all the terms is 90. Okay, find the value of n. Okay, so the sum of the n term will be 90, and we have to find the value of n. So step by step, we have this. We have to find something from this. The fifth term is equal to 12. Now fifth term, that will be where n equal to 5. We have 12. A is going to be 6 plus n minus 1 is 5 minus 1 is 4 times d. We have this equation, so we have to find the value of d first. So for d will be 6, d will be 3 over 2, which is 1.5. So now, since we know the value of A is 6, D is 1.5, we know the sum of the first n term will be 90. We want to find the value of n. So let's form another equation, right? So you will have, replace here, half times n, we don't know. 2 times A will be 12, plus n minus 1 is, we don't know, right? N minus 1 we don't know. And D will be 1.5. That is going to be the value of 90. Now we can solve. Multiply by 2. That will become n. 12 plus n minus 1 times 1.5. That will be 180. Just cross multiply, right? Send this over here. Now we can expand this and see what happens. That will be 12n plus 1.5 n times n minus 1. That will be 180. Now, I think I don't like to work with decimals. I can multiply by 2 to make this become a whole number. That will be 24n plus 3n times n minus 1. That will be 360. Now let's continue. Now we have 24n plus the value of 3n squared minus 3n. That will be 360. Now 3n squared was what? 24 minus this. That will be plus 21n minus 360 divided by the value of 3, that will be n squared, plus 7n minus 120. Okay, so now we have to find the value of n from this equation. So step by step. Now again, you can use factorization, it is up to you, or we can use what? So we have 120 divided by 5 is this, 120 divided by 12, so 120 divided by 8 is 15. So here we can use this. So 120 is equal to 8 times 15. Now of course you can use your formula as well to find the value of n directly. So factorize, in my case, that will be n times n. 120 is 8 times 15. To get plus 7, I have to have plus 15 minus 8. N will be this, n will be the value of minus 15. Again, so n is a number of term, can only be positive, so n will be the value of 8 as your answer for the number of terms of the progression. Let's move on to the next question. The diagram shows a semicircular prism. As you can see, we have a cross-section area is a semicircle with a horizontal rectangular base ABCD. So ABCD. Now this is given to you in the diagram. Now the vertical ends are AED, and BFC. Okay. The radius is 6, this is 6, this is 6, and this is also 6. These are the radius values. Okay, so what's next? The midpoint of AD is O and M right here. Okay, good to know. And the points E and F are the highest points on the semicircle. Okay, good to know. These are the highest points on the semicircle. Okay, the point P lies on EF such that EP is 8. Now we can conclude something here. If this is 8, it means this will have to be 12, right? Because the whole thing is 20. 20 minus 8 is 12, obviously. Let's move on to the questions. Now, using I, J, and K, for this one, in terms of I, J, and K, we have to find vectors PA and PN. Let's first find PA. So finding PA means from P go to A. So let's see how can we find this. From P going to A. P is right here. We have to go to A right here. So step by step. As you can see, we first have to move from P to go back to E, right? P going to E. And then from E we can move down to O. And then finally from O we can go to A. That's how we can move from P to A. Now let's find those values one by one. So P to E. Now because J is in this direction, right? We understand that going from P to E will be in the opposite direction. So I have to be negative J. And the length is 8. That will be minus 8J. That's the first step. Now EO, from E going down to O. But now we know O going up to E in this direction it is K. But going down now in the opposite direction have to be minus K. So minus, this value will be 6 because it's the radius, k, plus OA, same way of understanding. I will be in this direction, but in this direction will be negative I, and the length is minus 6i. That will be minus 6i minus 8j minus 6k. That will be part 1 of your question in finding PA. The next one, we have to find Pn. From P going to N is right here. Again, step by step, no need to rush. What is the first thing you can do? So from P, let me write this over here. P going to N. From P, I can go to E. Again, P going to E. Right. E, I can go back to O. Okay. And O, I can go to D. O going to D. And then D going to N. Okay, as you can see, step by step, we were able to move from P N to N. So these first two values we know already. So P is minus 8j plus minus 6k. So OD, O going to D will be 6i, obviously, because I is in this direction and the length is 6, that will be 6i. And then DN will be in this direction. This length is given to you by what? So N is the midpoint, right? N is, let's see, where's N? So the midpoint here, the midpoint is N, which means this is 10, and this have to be 10. So D to N, that will have to be value of 10. It is in this direction, that will be J. So simplify, you will have 6i, 10 minus 8 will be plus 2j, and minus 6k. So these will be the values of Pn and PA for part 1 of your question. Now moving on. We have to use scalar product to find the angle APN. So from P, this, and this. So now we have all the vectors we need already. We just need to use the formula we know for finding the angle, which is PA dot of PN, that will be magnitude of PA, times magnitude of Pn, cos of the angle APN. So we just have to replace back in this formula and then solve for the value of P, which is the angle. Now PA, we have found this was given to you by minus 6, minus 8, minus 6. Pn was found to be 6, 2, minus 6. So to find the magnitude is pretty easy. We'll just have to square the value. So minus 6 squared is 36, plus 64 plus 36. That will be root of 136. Now for this one, same thing. Square of 6 will be 36, plus 4 plus 36. That will be 76. Cos of the angle APN. Now let's try to simplify this. Minus 6 times 6 plus minus 8 times 2 plus minus 6 times minus 6. That will be minus 16. That will be 136 and 76 of cos of APN. Now we have to make cos become subject, so you have cos of APN is equal to minus 16 divided by this value, right? And then the last step is pretty simple. We just have to find the angle APN will be cos inverse of this whole thing over here. Okay, so minus 16 divided by root of 136, root of 76, this, and then cos inverse of that will give you 99.05. Correct to one decimal place will be 99.1 degrees. And that will be your question, part 2, to finding the angle APN. Let's move on to the next question. The function f is defined by this, okay, from 0, ax is from 0 to 360, where a and b are positive values. Good to know. The maximum value of f of x is 10, and the minimum value of is minus 2. So we have to use that information to find the value of a and b. So step by step, we know that f of x is equal to a minus b cos of x. Now, the only thing changing in this equation is obviously cos of x, because a and b are constants. Now we know that between the values of x is between 0 and 360, cos of x can take the value of -1 and 1. Now we have to check. When is, so we know that the maximum value is 10. When is f of x maximum? That will be a minus b times -1. So that will be a minus become plus b have to be 10. That is my first equation. Next one, obviously, we know the minimum value have to be -2. That happens when a minus b times 1. That will be the value of -2. So we have a minus b will be -2. Equation number 2. So let's solve one by one. A will be 10 minus b. And here we have a will be -2 plus b. Replace, you have on one side 10 minus b will be -2 plus b. We can send this over here, that becomes 2b, and that will be 12. So b will be the value of 6. Which means a will have to be -2 plus 6, that will be the value of 4. Okay, that will be part 1 of the question. Okay, so one thing I think I would like to explain as well is that, because it could be confusing, right? When we have a minus b cos of x. Now, the maximum value of cos x is 1, and so this is the max. And the minimum value of cos of x is equal to -1. Now, we know the function is maximum. When does that happen? So, because here we have minus, we would say a, when you minus the minimum value, that will give you the maximum value. And here we have a as well. When you have to minus the maximum value, that will give you the minimum value. Again, that was used in part 1 to find the answer. I hope that makes sense, because this is kind of important to understand how we derive those two in part 1. Now for part 2, solve the equation this equal to 0. So let's find out. So right now we have a is the value of 4 minus 6 cos x, that will be 0. 6 cos x will be the value of 4. Cos x will be the value of 2 over 3. Since cos is a positive value, will be in the first quadrant, and in the fourth quadrant, that will be x will be cos inverse of 2 over 3, right? That should be 48.2. That will be 360 minus 48.2. That will be 311.8. So these will be the two values of x that we have for that equation. Now for the last question, we have to sketch the graph of y equal to f of x. Pretty easy. As always, we would go back to making a table of values. Y equal to f of x is 4 minus 6 cos x. That will be my x value and my y values. I'll begin with 0. And the interval here will be 90, because here we have 1. 90 divided by 1, that will be 90. So here we're 90, 180, 270, and 360. So first thing first, we have 4 minus 6 cos 0. That should be minus 2. Cos 90, that should be 4. Cos 180, that should be 10. 270, that should be 4 as well. And then 360, that should be minus 2. Okay, so here we have our table of values. We can sketch the graph pretty easily. For example, that will be a y value and your x values. 0, 90, 180, 270, and 360. That will be minus 2 over here, and here we have the value of 10. And let's say 4 is somewhere over here. Right, 4 is somewhere over here. So it is only a sketch, doesn't need to be exact, right? We just need to have the shape of the curve. So 0 minus 2 will be right here. 94 should be somewhere over here. Then we have here And finally, we have this over here. Again, of course, you will try your best to make it bigger and better than this, because I'm just sketching this one as quickly as I can. However, you will take your time to make them as smooth as possible. As you can see, that will be some of the shape of your curve. You have to label that as y equal to f of x. And you will be using a pencil, obviously. And that will be the question part 3, where you have to sketch the graph. Let's move on to the next question. In the diagram, we have the circle has center O and radius 5. This is 5, center is O. The points P and Q lie on the circle, okay? And the length of PQ is 9. The length of PQ is 9, okay? This is 9 right here. Now, the tangents to the circle at P and Q meet at the point T. Here we have the point T, but we know that PT and QT are tangents, which means this is 90, and this have to be 90. Okay, great. Now we have to find the angle POQ in radians. Angle POQ, we have to find this value here. Pretty easy, because we know the length of arc is given to you by the formula r times theta. R is 5, the radius, theta is the angle, have to be 9. Theta will be 9 divided by 5 to find your value. That will be 1.8 radians as your value for the angle in terms of radians. Okay, now for part 2, we have to find the length PT. PT will be this length. How can you find this length? So let's observe. We can first kind of break this down into 2 pieces. Half, half, right? This will become 1.4, obviously, because the whole thing, sorry, this is not 1.4, will be 0.9. Because the whole thing is 1.8, so 1.8 divided by 2 is 0.9. Now if you observe, we have a triangle. That will be what? We have a right angle triangle. Here we have 5, and here we have the value of 9. And sorry, this is not 9. Apologies. This is 9 here, and this is 0.9. And we're trying to find the length of PT. So PT. So pretty easy. We can use SOHCAHTOA, obviously, right? So SOHCAHTOA, let's see which one we will use. So we have this side. This is my A side, A and A. We're trying to find the O side. We have to use this. That will be tan of 0.9. Will be the opposite side will be PT over the A side. So PT will be 5 times tan of 0.9. We have to use radians over here. That will be 6.30. The length of PT will be 6.30 centimeters. Now what else? We have to find the area of the shaded region. So one by one, we can first find the area of this of half. So we forget about this one first because they're the same thing, right? I think we have seen this kind of question many times as well. Now we have somewhat of an understanding how we can proceed step by step to find that area. So we can forget about this half and look at this only. Find the area of the triangle first. That will be half times base is 5 times height will be 6.3. That's the area of the whole triangle. Half times 5 times 6.3. That should be 15.75. Now you want to minus the area of sector, which is the one that we don't want here. That will be half. R square is 5 and the angle is 0.9. So answer minus half times 25 times 0.9. That will be 4.5. So 4.5 will be the area of this side, and we also have this side, so times 2, that will be 9.0. So 9.00 centimeters square for your area. And that will be your question in relation to circular measure. Let's move on to the next question. A wire which is 80 centimeters long is cut into 2 pieces. So 2 pieces, okay? Now the total length of both pieces will be 80 centimeters long. I hope that makes sense, right? Now one piece is bent to form a square of side x. This is x, 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 and x because it is a square. And the other piece is bent to form a circle of radius r. So circle of radius r, what is the circumference of a circle? That will be 2 pi r. Okay, that will be the circumference of a circle. Now, the total area of the square and the circle is A. Area is A. So we have to show A is equal to this. Okay, so before we proceed to show A is equal to this, we have to first use that information. The total length of A and this one will be 80. So let's find that out. So what is the length of this? That will be x, 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 and x. That will be 4x plus 2 pi r have to be 80. From this, I can find the value of r. So 2 pi r, 80 minus 4x. R will be the value of 40 minus 2x over pi. That is the value of r, right? Now to find the area of both the square and this one, let's see what can we do. So area of a square is x squared, right? Length times width, plus area of circle is pi r squared. Pi r squared is r squared we don't know yet. So let me replace. A will be the value of x squared, pi is pi, r squared is 40 minus 2x over pi squared. Simplify. That will be x squared, pi, and that will be 40 minus 2x squared over pi squared. So this and this will cancel out, and here we will have x squared plus the value of, so here we have 40 squared, that will be 1600 minus 40 times minus 2 times 2, that should be minus 160 x and plus 4x squared over the value of pi. Now we can simplify, obviously, make them have the same base. That will become pi over here, and here we can have x squared pi plus 1600 minus 160x plus 4x squared. Now we can see here we have x squared and x squared. We can combine them. That will become x squared factorize pi plus 4. And we have minus 160x plus 1600 over the value of pi. Now we can just rearrange to show it is exactly the way we want to show this. So A can be pi plus 4 x squared minus 160x plus this value over the value of pi. That is your area. Now for part 2, given that x and y can vary, we have to find the value of x when a has a stationary value. Now we know that when a has a stationary value, we have to think of dA by dx have to be 0. Okay, so let's find that out. dA by dx will be what? Now this is only a multiple. We can take this out for now. Here we have to multiply by 2. This is also a multiple, right? We can take it out so I don't confuse you guys. This is only a multiple. That will be outside. Multiply by 2, that will be 2, and we have x remaining minus 160. So you have, so this is dA by dx. Now we have to equate to 0 because this is at the stationary value. Now we can first cross multiply. This will cancel out. You have 2 pi plus 4x minus 160. That will be 0, which means we have to find the value of x here. So x will be 160 divided by 2 pi plus 4. Let's see what do we get. 160 divided by 2 pi plus 8. That will be 11.2, correct to 3 SF, right? Centimeters. And that was the question, just to find the value of x for which a has a stationary value. Okay, so that would be a question. First we have to kind of derive the value of a, so it is not too hard, but first we have to realize we have to use this value. It is given to you for a reason. So we first have to find the sum of the length of both shapes. We get this. Now here, how do I know I need to make r become subject? Is because in the show equation here I don't have any r. So it means that I need to find r in terms of x. So eventually, when I replace back here, everything will be in terms of x. So that's the idea behind r being a subject. Now moving on, we have this and this, then we have to solve one by one to find the value of x. Let's move on to the next question. So the equation of a curve is given to you by this. Now we can rewrite this down as 5 minus 8 power x minus 1. Now part 1, we have to show the equation of the normal to the curve at the point P is this. So let's find that. Now, to find the equation of normal, we understand that we have to first find its gradient. So to find gradient of normal, we have to find the gradient of tangent first, because that's what we can find first. So this is simply dy by dx. That will be pretty easy. That will be 0 here. Then we have plus 8 x minus 2, 8 over x squared. Now dy by dx at the value of x equal to 2, right here, x and y, 2. That will be 8 over 4, that should be 2. Which means the gradient of normal have to be minus half. And the passing point, 2, 1, that is x value and y value. So y minus 1 over x minus 2, that will be minus half. Then we can try to cross multiply to see what happens. That will be 2y minus 2 minus x plus 2. 2y will be minus x plus 4. Or 2y plus x is equal to 4, shown as required. Now this normal meets the curve again at point Q. Find the value of point Q. So now again, meet, cut, intersect means we have to solve a simultaneous equation. The curve is given to you by this equation. And we have x here. Let's make y become subject. So y will be minus x plus 4 divided by 2. Replace on one side, you will have minus x plus 4 over 2 has to be 5 minus 8 over x. We can try to simplify. First multiply by 2, you will have this. Then multiply by x to cancel this one, that should be minus x squared plus 4x equal to 10x minus 60. Send everything to one side, you will have x squared. We have 10 minus 4 will be plus 6x minus 18, that will be 0. So we can factorize. That will be x, and 16 is 2 times 8. That will be plus 8 minus 2. X will be 2 and x will be minus 8. So here we have the two values of x, but now we know that already the normal meets the curve at when x equal to 2. We don't need this one, we need to find this one. So for y, it will be what? Replace back in the curve, that will be 5 minus 8 over 8, that will be 5 minus 1, that should be 4. The other passing point Q will be minus 8, 4. This is just P, it is given to you already. We don't need to refine this one, we just need to find Q as follows. Now let's move on to part 3. So find the length of PQ. So PQ, pretty easy. We have P given to you by 2, 1, and Q was found to be minus 8 and 4. So from this, okay, I think I made a mistake here. If the value of x is minus 8, that will be minus 8, and that should be 5 plus this, that should be 6. Right? Okay, here you go. Now we have the two values we need. We can find the length. The length will be square root. First we have to do this minus this. So minus 8 minus 2 will be minus 10 square, that will be 100. Plus 6 minus 1 is 5 square, is 25. That will be 125. So the length of PQ will be root of 125. Or we can simplify. Square root of that will be 11.2 units, correct, to 3 SF. Let's move on to the next question. The diagram shows the curve y equals to this, root of 3x plus 1. Now, as we have seen many times before, the first thing we can do here is to rewrite the equation. This is also equal to 3x plus 1 power half, right? That's the first step. Now, we also know that we have a point P and Q, they are both on the curve. These are the given values that we might use sometime later. Now, the shaded region is bounded by the curve, okay, the y-axis and the line y equal to 2. As you can see here, we have a region. It is bounded by the y-axis, the line, and this one. Now this is the equation of, let me kind of complete this. This is the line that we have here, which is y equal to 2. Great to know. Okay, so part 1, we have to find the area of the shaded region. Okay, so how can you find this area? So we have to observe and think step by step. So to find this area right here, we can first find the whole area, right? Let's do that first. Now, how can you find the whole area? So by observation, you can see we have a rectangle for the whole thing. So number 1 is area of a rectangle. How do you find this? It is length times width. Length is 1 times width, it is 2. Because this is the value of 2 here, 2, right? So the whole area is just 2 units square. That's the first part. Now to find only this one, we have to remove this part of the area. Now to remove this part, it is what it is, as you can see, it is area and the graph between the limits of 0, 1. So number 2, that will be integration between 1 and 0, sorry. And then that will be the curve that we have been given by the question. So we want to remove this part to find the area that we need. So one by one, this is simple integration. You first have to increase the power by 1. That will be 3 over 2. Divide by the same power. And then divide by d by dx of the value inside. That should be 3. Simplify, you will have what? So 2 will go up. That will be 2 over 9. So 3 times 3 is 9. Times 3x plus 1. 3 over 2. 1 and 0. So let's continue on top. Some space over here. You can see 2 over 9 is only a multiple. We can just take this outside. That will be 2 over 9. On the inside we have, first we put the value of 1. That will be 4 power 3 over 2. And then we put the value of 0. That should be minus 1 3 over 2. Let's see what happens. 4 power 3 over 2 is 1.5. That should be 8. 8 minus 1. That should be 7. So 2 over 9 times 7. That should be 1 5 over 9. Now this is the area of this part that we do not need, right? Now to find the area that we need, we take the whole thing, which is 2, minus the one that we don't need. Let's see what do we get. 2 minus answer should be 4 over 9 units square. So this is the answer for question part 1. Now for question part 2, we have to find the volume obtained when the shaded region is rotated through 360 about the x-axis. Now usually when we have a rotation about the x-axis, we have to know which formula we are going to use. So about the x-axis, we know we have to use volume is equal to this, and of course integration, and that have to be y squared with respect to dx. When we have about x-axis, we have to make y become square. But again, this is usually what we have to use. But now we have to understand the context we have over here, because here we are trying to find this volume when this area is rotated about the x-axis. There's 2 parts we kind of have to think about here, because it is not that direct in this case. So at first we want to, because we understand the area here was the area of the whole thing minus the area below the curve. Now volume, again, is the same logic. It's the volume of the whole thing minus the volume of the inside part. So how would you find the volume of the whole thing? So if you think about this, here we have the x-axis. At first, we have to look at this line. Now when you rotate this line about the x-axis, for example, you have x here, rotate about the x-axis. If you think about this, it will give you what? It will give you a shape like this, right? So please use your imagination for this question. Well, let's see. Let me draw something here. So this is the x-axis, for example, right? And I'll rotate the line around the x-axis. For example, you will have a shape something like this. That makes sense. When you rotate this one around the x-axis. Now, this is the radius. The value is 2. Radius is 2. And the height is just 1. So what is the volume of this whole thing? It is the volume of a cylinder. So pretty easy. Volume of the whole thing is pi r square h, which is pi. R square is 4 times 1. That is, h is 1, right? It is the height. It is 1, as we can see here. That will be 4 pi for the value of the volume of the whole cylinder. Now, we don't want the volume that is below the curve that is rotated about this object. So we have to minus that volume. So that volume will be found pretty easily by using your formula. So unwanted volume that will be, limits is obviously 1, 0. Pi is pi. Now what is y square? Y is this value square. That will cancel out. You will have 3 x plus 1 respect to dx. Now we can take this out. It's only a multiple. You will have 1, 0, 3x plus 1 by dx. Now simplify. Pi is pi. That will be 3x squared over 2 plus x. 1, 0. Pi is pi. That will be 3 over 2 plus 1 minus 0. So let's see what we get here. Pi is pi again. So 3 over 2 plus 1, that should be 2.5. So the unwanted volume is 2.5 pi units cube. Okay, so what is the volume that we need actually? So pretty easy. It is the whole thing, the whole volume minus the unwanted volume to find the one that we actually need. So the whole thing was found to be 4 pi minus 2.5 pi. That will be what? 1.5 pi. Let's check. 4 minus 2.5 is 1.5 times pi. Should be 4.71 units cube for volume. So correct to 3SF. That'll be part 2 of the question. Again, this one requires somewhat of your imagination. You have kind of think of this. We cannot find the volume directly, obviously not in this case. We have to kind of think what can we do first to find that, right? That will be part 1 of the question. Let's move on to part 3. Now tangents are drawn to the curve at the points P and Q. Okay, so point P is given to you here, point Q is given to you over here. Now, we are trying to find the acute angle in degrees correct to 1 decimal place between the two tangents. Okay, so this one is not too bad. It is pretty easy actually. But I don't know if that is still in your syllabus, so please do check and let me know if that is still in your syllabus, but it is pretty easy. Let's move ahead with the question. Now, to find the angle between two tangents, we have to find the slope of the tangent, which is simply the gradient of the tangent. Now we know to find the gradient of tangent, we have to find what? dy by dx. So y was given to you by 3x plus 1 power half. From here, dy by dx will be what? Half 3x plus 1. That will be obviously minus 1 minus half multiplied by 3. That should be 3 over 2 3x plus 1 power minus half. That should be 3 over 2 3x plus 1 power half. That is dy by dx. Now, we want to find the slope of the tangent at the points P and Q. Now, and this is the x value and the y value, and the x value here as well, y, x, x. Now we have to find the slope, we have to use the x value. So at the point P, we know the x value is given to you by 0. Replace back in here, you will have 3 over 2 times 1, that will be 1.5. That's the slope of this one. Now the point Q, where the x value is 1, you will have 3 over 2, 4. So 3 times 1 is 3, plus 1 is 4, power half is just 2. That will be 3 over 4, and that should be 0.75. So now we have the slope of both tangent. We can find the angle in between pretty easily. So again, the angle at first will be what? Modulus of tan inverse of one of them, let's say 1.5, minus tan inverse of the other one. So tan inverse of 1.5 minus tan inverse of 0.75. That is 19.4 degrees as your answer. But now sometimes it may give you a value which is more than 90. If that happens, you can just take 180 minus the angle to find the acute angle in between. In this case, we have something less than 90. It is acute already. So that will be your answer for the acute angle right here for the question. But now, as I explained, sometimes you may have an angle which is more than 90. If that's the case, and if they are asking you for something acute, you just take 180 minus the whole thing. In this case, it is just perfect, and that will be your answer for question part 3 in finding the angle between two lines, in this case two tangents. Now let's move on to the next question. The function f is defined by f of x equal to 3x minus 2. Now x can take any values, great to know. Sketch in a graph. Sketch the graphs of this and this, making clear the relationship between those two. So pretty easy. As we have seen many times before, the relationship is simply, it is a reflection between the line in the line y equal to x. So we'll have something like this, x and y value. So we have to kind of draw this line, y equal to x. And then we know this is obviously a straight line. So when x equal to 1, that will be 1. So when x equal to 1, the value of y will be 3 minus 2 is 1. So 1, 1 should be on the line. Right. And when the value of x equal to, let's say 2, that will be 2, 3 times 2 is 6, minus this should be 4. So it will be way upwards, somewhere over here. So that will be the shape of the graph in a way. That will be y equal to f of x. Now, obviously, it is a reflection, so we'll have something like this. Kind of, let's try your best to sketch. That will be the inverse, y equal to f inverse of x. Okay, so that is pretty simple. It is only a sketch, doesn't need to be exact, but we have to show the shape of this line, but also the relationship between those two. Okay, that is part 1. Now for part 2, we have g of x is this. Now we have to express what? G of x in terms of x. So let's do that. G of x will be 6 f of x minus f of x square. That will be 6 times f of x is 3x minus 2 minus 3x minus 2 square. That will be 18x minus 12 minus 9x square. That will be 2 times 3 will be 6 times 2 will be minus 12 plus 4. So simplify. 18x minus 12 minus 9x square plus 12x and minus 4. Let's see what you have. You will have minus 9x square. 18 plus 12 will be 30x minus 16. That will be this one. And then show the maximum value of f of x is this. So how do you find the maximum value? You know it is found by, first we have to find d by dx of this. That will give you minus 18 plus, so minus 18x squared, so x, sorry, that'll be minus 1. And then we have plus 30. We have to equate that to 0. So x will be the value of 30 divided by 18. What is that value? 30 divided by 18. That should be 2/3. Now replace back in your equation to find that value. So let's see. Minus 9, so we have answer here is this. Good to know. Minus 9, answer square, plus 30, answer, minus 16. That should be 9. So shown as required. This is the maximum value is 9. So this is when x equal to this. The max value is indeed 9. So the reasoning behind is pretty simple as well. To find the max value or the minimum value, we know we have to perform differentiation. That is one of the methods, obviously. Now, this is the main equation. So we have to differentiate that. You will have this equation. Then we know that at the stationary value, obviously dy by dx, as we have seen before, has to equate to 0. So equate to 0, find the value of x. So when x equal to this, we have shown the max value or the stationary value is 9. But how do we know it is a max value? Because the coefficient of this of x squared is minus 9, which means it is going to have a shape like this. This will be the maximum point. So shown as required. Now for part 3, we have the function h is defined by this for x more than 3. Okay, good to know. Now we have to express this in terms of this. So step by step. So first we have to rewrite this as minus x squared plus 6x. Let's make this become 1. That will be factorized. That will be x squared minus 6x. Then we have x squared minus 6x plus the value here is 6 over 2 squared. Now when you add something, you also have to minus the same value. Because here we have minus 1, we have to give it, because it is inside the bracket, we also have to give it minus 1. That will become plus this value. So here we have minus, and that will become what? X, here we have minus, that will become 3 square plus the value of 9. So that will be 9 minus x minus 3 square. Now we can compare. This is A and that will be B. Okay. Now apart this, we have to find h inverse. So let y equal to h. So x minus 3 square is equal to 9 minus y. X minus 3 will be plus minus 9 minus y. X will be 3 plus minus 9 minus y. But now obviously you will take the value in terms of x and the value of positive 9 minus x. The reason why we take plus here is because it is defined by x more than 3. Okay, that's why. Okay, and that will be your question. We have to express h inverse in terms of x.